Thank you for logging in. In today's podcast, I'm looking at the factor theorem. We're asked to show that x plus 2 is a factor of the cubic equation. So here, f of minus 2 is minus 8 plus 38 take away 30, which is the same as 38 take away 38 . So f of minus 2 gives us 0. Therefore, we've shown that x plus 2 is a factor. The second part of the question, we're asked to factorise the cubic completely. So here, we'll rewrite x cubed minus 19x minus 30 as a product of the linear factor x plus 2 times by the quadratic, which is ax squared plus bx plus c. If we now look, we've got the x plus 2, and if we look at the coefficient of the cubic, we'll notice that it's 1. The coefficient of the linear x is 1, hence the x squared will be 1 as well. If you look now at the constant, which is negative 30, we already have 2, so that must be negative 15. And that will be plus bx. If we now look at the coefficient of the middle term, which is just the x, we'll notice that it's negative 19. So by comparing the coefficients, we'll see that if you multiply the x by the negative 15, that will give us negative 15. And if we multiply the 2 by the b, we get 2b. If we take the negative 15 over, we're left with minus 4 equals 2b, and then b falls out as negative 2. Now the last part of the question is to factorise. So we have x plus 2, which is the linear, then we have the quadratic, which is x squared, minus 2x, minus 15. The 15 is made up of 3 and 5, leaving a difference of 2, which can be written as x and 5 and x and 3. We know that the initial factor is x plus 2, and in order to get a difference of 2 which is negative, that will be negative 5 and it would be plus 3. In this question here, again we're asked to show that x minus 2 is a factor. So here we're looking for f of 2, which will give us 2 times 8 minus 4 plus 4 minus 16. And you can see clearly that that's going to be equal to 0, but it's always a good idea just to show all your workings out. So the 16 minus 4 plus 4 minus 16, and as you know that gives you 0. So therefore x minus 2 is a factor. Again, we'll use comparing coefficients to answer part B. So we have the cubic, which we'll express in the form of the linear and the quadratic, and then find coefficients B and C. You'll notice here we'll be given the value of A as 2. So that's 2x squared plus bx. We need to get negative 16. We already have negative 2, so that must be plus 8. In order to get the value of b, we will compare the x coefficient, which on the left hand side is 2, and on the right hand side, if we multiply x and the 8 together, we will get 8. And if we multiply the negative 2 by the b, we get negative b. And this can be tidied up to give us b equals 3. So we have 2x squared plus 3x plus 8. The third part of the question asks us to show that we only have one real solution, which will be x minus 2, so this quadratic will have no real roots. You can recall your determinant work where b squared minus 4ac, if it's less than 0, means that no real solutions exist. So here we'll use the quadratic and we'll evaluate b squared minus 4ac, which will be 9 minus 4 times by 2 times by 8, and you can see that that is clearly less than 0. Therefore, only one real solution exists, which was the original factor of x minus 2. If we look at these graphs, the red line, the red curve, is the original fx function, which is a cubic, cutting the y-axis, intercepting at minus 16, and the blue curve you can see has no real solution, which is a quadratic.